All right, it says this Hangout on Air is live. Hey, welcome everybody once again to Astronomy Daily Live. Hope everybody's doing well out there. Everything's good. Pretty good. Good here. Just sort of a normal day. It's still cloudy, and we're expecting some storms here too. I guess it's already hit the coast of California, so it's on its way. So cloudy, and so there I am.
We got an echo from somebody.
Yeah, it's on its way. That's got to be a Bobby. And Bobby likes to make all kinds of noises. All right, well, cool. Yeah, so hope everybody's doing good. As I said, everything is good here. I did cancel yesterday's live stream. I just wasn't here. I went to a I forget exactly what it's called, but it's a what is that thing called? Let me I should have looked this up beforehand, but it's a
House of Ill Repute.
Yeah, something like that. Yeah. So it's a monthly thing that takes place usually either in Tucson or Phoenix. It's called the Arizona Space Business Roundtable, and it's just I don't really like going to meetings and all that kind of stuff, right? Because it's just a lot of pressing of palms and exchanging business cards and that kind of stuff, and that's just not really my scene all that much. But I'm a space nerd, so I'm extremely interested in these kinds of things, so I can overcome that foul taste in my mouth and go and once I'm there, I usually thoroughly enjoy it, and this was that kind of a thing, right? Get to meet a few pretty interesting people. I shook the hand of somebody, I forget exactly, I don't have his card here, but there's the speaker was the CEO and founder of and I'm just looking that up now. Where was he from? From AQST, Space Systems Group. They are a rocket company who hasn't actually launched a rocket yet, but they're soon going to, from a spaceport that is being planned to be built in Yuma, which is an extreme southwestern part of the state, right on the California border. So so that was the speaker. I also got to meet somebody from Vector Space Systems, which is a Tucson-based rocket company. So it's kind of cool.
So is it more of a business-based gathering, or is it
business?
Talk about? Oh, right, it's business. Yeah. Okay.
Business. Yeah. So, and that's why it was just a bunch of yakety yak and shaking hands and business cards and all that kind of stuff. And
money.
What's that?
We want your money.
Yeah, no, they're trying to do, they're trying to create a ecosystem, as they call it, a space-based thing, and space is the future. As long as we don't blow ourselves up, we are definitely going to be expanding that way, because if nothing else, we are explorers, right? And we want to know what's over there, right? So if we don't destroy ourselves, we're going to just be expanding and expanding and expanding. Anyway, so that's where I was, and it was a little bit of fun. But before I go too much further into this, definitely want to say howdy to everybody on the panel. So, hey, Bobby, how's that network going? Is it working?
Yeah, it's still doing good and stuff. I just got done with my shortwave show.
Very cool. Which shortwave show was that?
It's a new one. It's a brand spanking new one. Just did it about 3 weeks ago.
Oh, I don't know if I heard about that. What? Tell us a little bit about it, and if you want to post a link anywhere, do it.
The show is called "This Is a Music Show." It features lots and lots of music, and it features MFSK64 text and an MFSK32 image. So you might want to get your FLD ready on that show.
Oh, very cool. So if you want to post a link to that over in the chat or over in the Discord, go for it. Yeah, that sounds interesting. That sounds.
I don't think he's got a website. But I can give you the website for WRMI. That's where he usually posts his show at.
Sure. Yeah. Whichever way we can find it.
It's gonna be like the best when it comes to commercial shortwave. WRMI usually has Prague, Tirana, Slovakia, Argentina to the world, which is usually Argentina. They also are doing the Voice to Report a week as well.
Of course, yeah. Where do they broadcast from?
Okeechobee, Florida.
Okeechobee. Yeah, I thought it was down there somewhere. So, okay, and how much power are they pumping out? It's like 100,000 watts or something. It's huge, isn't it?
Yeah. And you and I showed you that video tour they did when we was on Rabbit.
Yes. Yeah, that's an amazing facility. So yeah, if you have the link to that video, that might be interesting to post over on the chat too. So yeah, it's kind of a, it's not astronomy, but it is definitely very, very nerdy, and I'm fully in favor of that. So yeah. Well, cool. Well, glad you're here, and all the way from the United Kingdom is Tim. Hey, what's going on over there?
All is cool here, thank you. All is cool here, thank you. Just got the car through the test today. No Wi-Fi tonight.
All right. So all the shenanigans are at Tim's place. Yeah.
I've got the women waiting in the bedroom right now.
I can hear them.
Dizzy Sue is gonna kick your butt.
Yeah, well, she can kick it all she wants, because tonight I'm getting it slapped.
I do exactly the same thing. When the wife is gone, the party starts, man, and it's like it's wild here. It is completely wild. I always have to ask very specifically, when are you going to be home? Because I want to make sure that I've got enough time, right? To clear everybody out, clean everything up, right? Make it look like nothing's happened, right? So, and that's all I can say about that. So
I should have some dancing pole dancers behind me. That would have been cool.
Yeah. Anyway, all right. Well, glad to have you here again, Tim. Always great to have you here. And I'm going to change one letter and say hi to Tom. Hey, what's going on?
Hey, Cosmic. Hey, panel. Hey, chat. Hope everyone's doing well. From what you just said, Cosmic, I'll take it that your wife never watches your videos.
Nice.
Never. Never. That's just not allowed.
And the cats don't ever tell her what's going on.
They have signed an oath.
They're
An oath
sworn
of silence.
sworn to
Yes.
secrecy. That's
Sworn to secrecy. Yeah. Absolutely. Absolutely.
Okay, so lots and lots of shenanigans you might be missing at the chat. Jim from Carolina Sky Astronomy said he
Hey,
just
Jim.
got a new EQ mount for his telescope. He had clear skies tonight, but his laptop died. He would be taking
Wow.
forward to get working. Uncle Bill Durham better launch at least one of their tests from Spaceport Camden here in Georgia. They have a Tron train. I think that's about it. And
Oh, cool.
we'll welcome another British invader who is Andy Calloway.
Yeah. Here, let me find. Hold on one sec. I want to show you Vector's business card. It's kind of interesting. Hold on a sec.
Well, Tom's not there. How you been, Tom? Mute.
Doing okay, Bobby. How you doing?
All right, got any trivia to give to me?
Well, we do have some trivia. I'll wait until we make sure we've got everybody, though.
I'm back. Do it.
Oh, okay. Well,
Unless
couple of
Tim. Do you want to wait for Tim?
yeah, we could wait for Tim. You
All
bet.
right. I'll show you this business card. For one, it's incredibly thick. Right? I know that you can't see that really well, but it's like a brick, right? And on the back, it's got, and I know that's not gonna focus really well. Maybe if I get it really close. Anyway, and then on the front, you see it's all, and sorry, that's not focusing. It usually focuses on my hand when I throw it up there like that, but it's not doing it now.
Just make out the Victor.
It's not doing a good job.
There we go. Well, it's not. There we go.
Ah,
There
Vector.
goes. There
That's it.
goes.
Anyway, so yeah, these are a Tucson-based. I think they're a Tucson-based company. They I've seen pictures of their rockets rolling down the city streets. So, but yeah, I mean, this thing is like a brick. You know, it's like 3 business cards.
So yesterday, this is like you and your boss went there, huh?
No, it's just me. Just me.
Oh.
I'm the space nerd at work, so. So yeah, but that was a lot of fun, but as I say, those kinds of meetings, I don't have a lot of strong interest in. I did go there and talk up the Lunar Observatory a little bit, and because I'm trying to get some traction on that, and the people I talked to about it, were like, wow, that is very cool. So that's all right. So anyway, all right, well, we are all back, and Tom has some tidbits of info there. I don't really like to call it trivia because that makes it seem kind of like not important, and I think these tidbits at least are very cool as far as I'm concerned. So what you got, Tom?
Well, thanks, Cosmic. That's nice of you to say. Got a couple of birthdays. First one is Joseph von Fraunhofer. He was born on this day in 1787. He passed away in 1826. He was a Bavarian physicist and an optical lens manufacturer. He made optical glass and achromatic telescope lenses. He also, this guy was pretty smart. He also invented the spectroscope and developed diffraction grating. And after he had invented the spectroscope, he discovered and studied the dark absorption lines in the spectrum of the sun. And those things are now called Fraunhofer lines.
Very cool.
Very, very cool.
Quite a guy.
Yeah, whatever happened to those kind of people, right? That do all these absolutely amazing things, right? I mean, we've sort of specialized a lot now, right? And a lot of that's gone.
Well, this is one of those things where he was kind of building up the foundation for some of these scientific principles. So the things he was looking at, no one had thought of before. So now those are kind of at the base of knowledge for us.
Here's a great book, right? Great book. Whoops, sorry, bent a little bit. But there's actually a picture of a Fraunhofer diffraction patterns. So there they are.
Cool.
Yeah. So, it's just an optical effect, but they can be taken advantage of to do very, very interesting things.
Do we not think that these kind of guys don't pop up anymore because it's already been said and done before? I mean, now we rely on technology for it all, which is pretty much, I won't say a learning curve, but the minds work better than technologies. For my money, it's already all been said and done.
Yeah, I think that there are still a lot of people in their garages and basements doing absolutely amazing things that we're just not going to hear about for a long time.
Oh, I concur.
At least I'm hoping, right? What do you guys think about that? Do you think that there are still some Fraunhofers around?
I think so.
Sorry, Tom.
No, I was just going to say, I think there are. Yeah, absolutely.
I hope so.
I
because we need them.
They've got blackboards and blackboards and blackboards full of equations, and they're just waiting to work out the finer details before they publicize it.
Yeah. Hey, here's a Fraunhofer diffraction pattern of a rectangular aperture and a circular aperture. So this should look familiar to most astronomers. That's just an Airy pattern. That's another name for it.
That looks like the ball patch on my head.
Yeah, it sure does. I can tell. Anyway, so yeah, and these kinds of things, this kind of diffraction can be taken advantage of to learn all kinds of things about what makes that kind of a pattern, the wavelength of light, the size of the aperture, the light is going through, all kinds of stuff, right? So yeah, great stuff. So Fraunhofer, excellent. What else you got, Tom?
The other is actually a contemporary. This person is still with us, and it is Valentina Tereshkova. She was the first female in outer space. She flew on the Vostok 6 mission for the Soviet Union.
I was just going to ask if that was Russian, actually.
Yeah.
Yeah, very, very cool. Yeah, I think the first American female was Sally Ride. Is that right?
I do not know for sure. It sounds right.
I think so. And that that was what, in the early 80s. So yeah.
Yeah, Tereshkova was in. She flew on June 16th, 1963, and spent almost 3 days.
Wow.
In space.
Yeah, yeah. And I think that is really, really great. But it's sort of a silly thing, to be like, wow, a woman can do that, right? That's ridiculous, right? Uh, shouldn't it matter what your gender is, right?
They
It's
sent a
like,
dog once, didn't they?
um,
Send a dog
yeah.
up with the Russians?
Oh yeah, yeah. And I don't know if the Americans sent up dogs, but they sent up at least a couple of chimps. Um, Spam in a can, as they called it, right? Uh-huh.
Cool analogy.
Yeah. Yeah, and I wouldn't be too surprised. I haven't heard anything about this, but I mean, was I guess Gagarin was probably the first human, to sort of be in space, right? He just sort of did this, right? He didn't actually go around or anything, but I've always been curious if the Russians tried a few others and failed, right? They died. Same with the Americans. I don't know if Shepard was the actual first. I sort of assume he was, but yeah, I don't know anything about that at all. But I wouldn't be surprised if there were some attempts that failed, right, with the people dying, right? But yeah, I've never heard anything about that. But yeah, has anybody ever heard any kind of rumors or anything about that?
I've seen rumors written that said that some Soviets died in space and no one was ever told, but never seen. I think they're just rumors.
Yeah. Well, like I said, I wouldn't be surprised, right? As they say, space is hard, right? And the people that are going now, right? No, are very much aware of the risk, right? We have enough data now to have a pretty good idea as to what the risk is in terms of going, and then once you're there,
Well, the first hazard is the takeoff, and a lot of people say the second hazard is the radiation belt.
Yeah, well, with low Earth orbit, you really don't have to worry that much about that. Yeah, and at least from what I've heard, if you're going out, you spend a very, very short amount of time actually going through the Van Allen belts. So I think the exposure there is real, but I think it's very, very short. Yeah, it's short, and I can only guess and or hope that there are ways to minimize that exposure too, with various kinds of materials and all that. But yeah. And yeah,
that dude. Did you ever see that dude that went up in space to a balloon and skydived from space?
Oh yes.
Yes.
He passed out on the way down, didn't he?
Not the one. Yeah, not the one I saw. This was a couple, maybe 2 or 3 years ago, and he wasn't actually out in space. It sort of depends on what you define as that. But I think he was up. Oh man, I don't remember how high up, but I mean, he was high enough up that the sky was black, right? There wasn't a blue sky anymore, right? Now, let me tell you something, right? I have absolutely no interest in skydiving whatsoever, right? I just, you know, I mean, I think it's really, really neat and everything else, right? But I'm just not going to do it, right? It's just, but if you put me up there where I can see a black sky, I will definitely jump from there, because I want to do, right, is I want to go down backwards, right, looking up. So as I drop, you know, the sky
falling away.
Yeah, goes from black to blue, right? I think that would be a great view. So you know, I'm not interested in sort of the regular skydiving, but skydiving from a platform that I think he was something like 160,000 feet or something. I mean, it's just some insanely high thing. I think it was the record.
Is it the same one, Matt, where they had radio communication and they were speaking to him inside the capsule, and they talked him out onto the platform, and then he said, "Right, I'm going for it."
Yeah.
Yeah, that'll be the same one. Yeah.
Okay. Yeah. And I heard that on his way down, you know, the whole drop took like 20 minutes or something like that, right? And I heard that on the way down, he actually his ground speed, right, exceeded the speed of sound, right?
Wow, I didn't know that.
Yeah, but you know, because of the atmosphere, you know, the speed of sound up there is different, right? So you know, I mean, he actually didn't you know for that location. But I don't know if that is true or not. But yeah, that must have been one, a great view, and two, a great ride. So you know, he was decked out in the spacesuit and everything. So yeah, that must have been a great view. You could actually see, you know, the curvature of the Earth and everything. So
if I remember,
yeah.
that was the one that he was spinning so fast he actually did pass out momentarily.
Did he? Okay. Yeah,
He lost
I'm
control.
trying to remember. Yeah, I'm trying to remember. I think that particular person has done it twice, and I don't. Yeah, I'd have to look up all the details again, but yeah, I would do that. I would definitely do that, just to get the view, right? So you know, I don't really have any interest in you know suborbital things. Not even the orbital. What's that?
30 feet. You've got bigger nuts than I have, mate. I'll do 30 feet and that'll be it.
Well, see, yeah, I mean, I have no interest in regular skydiving at all, right? That isn't extremely interesting at all, you know, to me, at least. But if I can get up really high and see a black sky in the middle of the day, yeah, I'll do that for sure. All right, well, cool. So, Bobby, is Blackie misbehaving over there?
No, my uncle gave me like a bag of chips and stuff.
Oh, all right. You got to feed the uncle. Okay, cool. Well, you know, that's nice to do from time to time. So, all right. Well, cool. Let's see. I'm gonna check on the chat really quick here. Make sure that there isn't anything.
Say something, but I don't know what he did want to say. This was about the internet. Might be something. I forgot what it was.
Okay. All right. Cool. I'm gonna actually check my new Nightbot.
I'd like to welcome Chuck now in the chat.
Hey there, Chuck. Nice to see you. So I'm creating a new series of Nightbot commands here based on when you're a when you're a panelist. If you have any kind of little blurb that you want to blast out about yourself, let me know, and I'll make one for you. So here's mine. It's definitely subject to change, but I want to try it out here. And I'm trying to figure out how to get Nightbot to do more than that many characters, but maybe maybe there isn't a way. So yeah, well, that worked. Cool. I might as well show you my weather too while I'm at it here over in the chat. So cool. That works really well.
Oh, I remember you fixed that before for my location, the weather one.
Oh, haha. I've got to do a location. It doesn't know where I am. Silly Nightbot. Here we go. There it is. Yay. Now it's saying that it's clear. It is the sort of the opposite of clear. So got high thin clouds. So I mean, it's a little sort of clear, but definitely not clear enough. So let's see if Tim's weather works.
Yeah, there we go.
Is that right?
That's correct. Yeah.
Cool. Excellent. Sometimes
southwest at 14. Yeah, that's pretty much right.
Okay. Sometimes Nightbot behaves, surprisingly enough. So
More so than the panel.
What's that, Tim?
More so than the panel.
Well, yeah, sometimes, yeah. All right, well, cool. I think what I wanted to do was actually get back to, we're still, I've got this little thing in the back of my head, right? It's going Leo, constellation Leo. We are still in the constellation of Leo, and as I recall, the last time we were poking around with that, we were looking at a galaxy called Messier 65. And I wanted to sort of maybe try to finish up with that today, just to, do our basic investigating of sorts. And so what I'm going to do is I'm going to pull up Sinbad here on my screen. And all right, so I've got Sinbad up. Sinbad is a great astronomical database for all kinds of things, right? So stars, galaxies, variable stars, clusters, all of it, right? It's a great repository, and for the most part, it's pretty up. The information there is nice and updated, right? So that's always nice. We have occasionally found some weird things with it, and I always like to find those anyway. But yeah, they I'm not exactly sure what their process is. I don't know if they have some kind of a system that goes into papers and actually extracts information and puts it into their databases, or if it's actual people, right, doing that. I'm not quite sure what the process is. Maybe it's a combination of both, right? But for the most part, Sinbad seems to be a pretty reliable source, used by most astronomers, and of course is accessible by everybody. So including us here. So I like to go there to just have it as sort of a jumping off point, if nothing else, right? Just from where we can sort of go everywhere, right? We can go to infinity if we want there. So so here we go. So here.
So Andy Calloway had a branded thing about the internet. It's just too bad. So white papers get lost. So we need more information where the papers are, so they can be studied.
Yes. Yes. That is absolutely true. That's something that we're going to have to, you know, well, I mean, we have to contend with it now, and you know, there's only, you know, it's only going to get. I mean, I don't like to say the word worse because that's sort of characterizing it not exactly right, but yeah, I mean, it's only going to get worse.
Unless, of course, we get that satellite internet that SpaceX and other people wants. The only way that we're going to actually get something to the world and stuff is usually on a regular radio.
Yeah, well, that's why I think, you know, things like augmented reality, where you know, you can sort of tune your VR to the kinds of things that you want to see and have access to, and all of that. And then, you know, those kinds of things that might be hidden, at least you're going to see, right? So that you know, that's kind of an interesting use for you know, this augmented reality stuff, and you know, I think that's a good thing, right? So, you know, use these machines as tools, right? I mean, that's exactly what they are, and you know, extremely versatile tools. Yeah, and I think that's a great use for that kind of a technology to you know, pull stuff out of the noise. So, all right, let's get to Messier 65 here, Messier 65, and see what we can find out about this fantastic galaxy. Now, this is a great galaxy to see through a telescope. I got to say that right off the top. So, you know, even with a relatively small scope, right? You don't need anything incredibly large to see this. It's actually, you know, if you, well, yeah, I mean, it's still relatively faint. If you look at the Sloan magnitudes here, U, G, R, I, and Z, you can see that at least in the visible bands, right, which is sort of U, that's moving towards the ultraviolet, but definitely G and R are in the visible band. It's, you know, 10th magnitude, maybe 11th or so. So, you know, I mean, it's not, it's definitely not going, you know, to jump out at you, right? But even with a 4-inch or a 6-inch telescope, you'll see this, no problem at all. And, you know, the larger the better in this case. Definitely interesting, though, that as you move into the infrared, right, J, H, and K, right, wow, it's getting really bright, really bright, which is sort of indicative, right, of a spiral type of a galaxy that has a lot of gas and dust that is really just nice and warm, right, glowing red. So so yeah, definitely interesting. It is an SA galaxy, and this B, I think, means that it's a barred galaxy as well. So it's got a bar in it. I don't know what this last A means. That might be the kind of bar. Don't quote me on that though. But well, why don't we start by taking a look at it here? And so these are various views. Now, I think we looked at this with HST the other day, so I'm not gonna linger too much with this. It's almost edge on, right? Almost edge on. Most spirals, I don't know if I can say all spirals, but most spirals are pretty round, right? Circular, right? But because we're viewing this at sort of a sharp angle, right? We see it sort of elongated in one axis and shorter in the other. These are usually called, the major axis here in the long one and the minor axis here. And so, to see this face on, we'd have to be, either out here to our right or over here to our left.
Or what?
I didn't hear all of that, Bobby.
Is that in the Leo triplet or what?
This is part of what is called the Leo triplet. Yes, yeah. M65 is this one, and actually, if we zoom out a little bit here, we'll see M66 right next door. There it is. And the third component is not a Messier object. It's an NGC object, a New General Catalog object. I think it's up there. There it is. It's
Again, is this in Orion?
no, this is in the constellation of Leo.
Oh, sorry, I beg your pardon.
Yeah, no worries.
Oh, cool.
Leo, yeah. So this is 65. This is Messier 66. And as I said, this is a NGC number. I don't have that number off the top of my head. Sometimes it's, and these common names are, I guess they help you remember them, but this is often called the Hamburger Galaxy, because I guess, it looks like a couple of buns with some meat in between, right? So, yeah, this, of course, is most likely a spiral galaxy that we're seeing edge on, right? So we're seeing this nice, very, very good-looking dark band here. Going all the way through, but there's some funny business here going on too, right? These edges, aren't sort of conforming to sort of the normal spiral shape. So what exactly is going on there? I'm sure there's some theories, but anyway, so yeah, this.
Okay, Jim's got an unusual question. Do you think there's somebody in that galaxy with a telescope taking images of our galaxy?
I have absolutely no doubt about that whatsoever, and they're probably as confused as we are, probably. So yeah,
Imagine they're looking at us through little glass lenses, though.
Who knows? Who knows? And really, we don't know what our galaxy looks like. Not from this perspective, right? We really don't know. We have a pretty good idea that we're in a spiral galaxy, right? The Milky Way is a spiral. There are some theories, though, that it might be a barred spiral. But we really don't know. To really know, we'd have to take sort of a full survey of you know all the stars, all the objects, everything else, and you know accurately know their distances and everything else, and that just isn't happening. We do have a pretty good idea from like radio data and you know looking at dust and gas and all of that. So you know probably I think we're pretty confident that the Milky Way is a spiral, but beyond that, we don't know much. And surveys like Gaia, right, which has mapped the positions of what, almost 2 billion stars, right? Well, that seems like a lot, but those are just the stars pretty much in the neighborhood here. So there are estimates that the Milky Way has 400 or 500 billion stars in it. So looking at only 2 billion stars, that's what 2 divided by 500. That's 0.4% of the population. So it's not really a lot of stars with Gaia at all, although it's the biggest survey we have at the moment, right? Anyway, so yeah, this is commonly called the Leo triplet, and usually, in an amateur-sized scope, you can put all three of these in the same field of view. It's pretty cool. So definitely, if you have a scope, 6 inches or larger, you'll definitely be able to see the Messier objects. You might be able to pick out this guy too. And again, I sort of say this every time, but when you look at these galaxies, right, with your own eyes, you are not going to see it like this. No, absolutely no way, right? What you'll see, and I'll sort of...
It's just pretty cool to look at other galaxies and think it's someone's on a planet and that galaxy is looking back at you.
Absolutely. I have absolutely no doubt about that whatsoever, right? I mean, yeah, those kinds of things just, I mean, they are extremely cool, to think about, but I have absolutely no doubt whatsoever at all. It's just a matter of time.
Learn how to explore other planets and the outer planets, moons and stuff, since we probably won't be able to go in those planets. And then you work your way to interstellar space, and then you work your way through a drama and stuff before you really can learn to explore the universe.
Yeah, I don't know what it's going to take, but it's extremely, I mean, based on what we know now, right? It's extremely unlikely that we'll be visiting any galaxies at all, right? The closest one, the closest large one, is 2 million light years away, and so traveling at the speed of light.
And it's not just that. Think about the consequences you may have when traveling through space.
Yeah. There are all kinds of interesting things to think about in terms of that, right? But yeah, well, we'll do as good as we can, but I can rest assured that there is very, very, very likely somebody in fact many in both of these galaxies that are looking back at us and thinking exactly the same thing, or almost exactly the same thing. But yeah,
it seems too wonderful that we're unique.
Yeah, well, the argument there, though, is Tim, is that somebody I mean, it seems logical, that something has to be first, right?
True.
So maybe we're first, but yeah, the universe, I mean, even if you agree with this idea of a Big Bang and 13.8 billion years ago, right? That's a long time, right?
They're 15.8 billion years ago.
Well, it's
yeah,
a long time in our time scheme.
yeah. So
Probably a
there's
short
lot
time
of,
in the grander scheme of things.
yeah. Well, all that is relative too. Yeah. Anyway, so yeah, I would definitely like to see our galaxy from with this kind of a view, right? To see exactly what it looks like, right? But we don't have a clue at all, except that's a spiral, and we've got a pretty good idea in terms of its size, but that's about it, right?
What's the furthest we have looked back at ourselves from?
Well, we can't really see our galaxy at all, right? Except from just our point of view here, right?
True, yeah.
So yeah, the furthest out space probes that we have now are, I think, did Voyager 1 and 2, did they pass up Pioneer? Don't remember exactly, but
Tom could probably answer that.
he might, yeah. So, but I mean, they're going to take 40,000 years just to get to the closest star to us, right? So, I mean, yeah, there's absolutely no chance of getting any kind of galactic perspective at all, at least not with those spacecraft. So, yeah, you got to solve the distance and/or speed problem. So, and
yes, Voyagers are the ones that are the farthest away. Pioneers are trying, but they weren't moving as fast. So
yeah, gotcha.
And wasn't there one spacecraft that took a picture of Earth from outside of Saturn? I think it was Saturn, where you could see Saturn and Earth in the same picture.
Well, yeah. Voyager did that. That's the pale blue dot shot, and then Cassini, the Cassini spacecraft did exactly the same thing from Saturn. So yeah, but that's of Earth, right? That's which is good enough, right? I think New Horizons, didn't New Horizons do dot as well? I don't remember. Anyway, there's M65 in all of its glory, and apparently it's kind of hard to tell here, but they're calling this a barred spiral galaxy, and it's hard to tell in this shot at least. This is from the Sloan Digital Sky Survey Release 9. I don't know if we can look at these in any other. As I said, we sort of looked at this with the HST, so I don't necessarily want to linger here too long. We've got more to look at here. So, like with most of these, it has a bunch of different names, right? Most of these are associated just, with the coordinates of it in the sky, right? That's what all these numbers are. Everybody sort of pokes fun at the numbers and stuff. I actually find these incredibly useful, right? That locates it in the sky, which I think is a nice thing. It's like, now I know where it is.
See, it's got the NGC as well.
Yes, 3623. Yeah, all the Messier objects have at least an NGC number associated with it, if not many others, right? pretty standard. So very well studied. We'll come back to that. Let's see. There's a bunch of distance and velocity measurements here. Let's see how far away they think this thing is. So, well, moderately.
Hey, Cosmic, are you on the Knowledge Fellowship Discord server?
Say that again, Bob. You broke up a little bit.
Are you on the Knowledge Fellowship Discord server?
I am. Why do you ask?
Yeah, because Alchemel Duran's got a just got a Facebook page, but it's not ready to go yet.
Oh, okay. All right. Well, when it is, he can advertise it here for what it's worth.
Yeah, I think
So-
Duran's going to do something like that.
Cool. So anyway, relatively good agreement here. There are lots of ways to measure distances, right? There are different methods, as they call it. This is the Tully-Fisher method, which I don't remember exactly what that is, but there's a redshift method. These two, they don't exactly say, but it's kind of interesting, right? That the redshift methods from two different researchers here are in pretty good agreement, but they sort of disagree with the other ones, right? That place it a little bit further out. But I don't know. Let's do an average here. This is maybe about 10 million parsecs away. So let's see. A parsec.
I've probably asked this before, but is the redshift movement an indication of the speed at which it's moving away?
It's both. Yeah,
I've probably asked this before. I apologize.
No, that's all right. We think that there's a relationship between how far away these galaxies are and how fast they are moving away from us. So the idea is that the faster they are moving away from us, the further away they are. Now, whether that's true or not, I don't know. There seems to be a correlation there, right?
Mm-hmm.
Because we can.
There's a warning if you look at the top about the IRAS, IRC, SAO, and CO.G, ECO, and GJ has been removed. But if you go to the base wire, you might be able to see some measurements from that.
Okay, cool. Very cool. Anyway, so yeah, there does seem to be a correlation there. Whether that's a real thing or not, I mean, a lot of astronomers, will say, absolutely settled science, right? Done, right? And that to me is a red flag, right? It's like maybe, we're, there's a certain level of confidence in that. Whether it's true, I don't know. Anyway, so let's just take the average here, which I don't know is maybe about 10 or so. So 10 million parsecs. Well, parsec is 3.26 light years, and then we want 1 million of those, and then let's multiply that by 10, and we get about 32.6 million light years away. So that's not incredibly close, but it's also not incredibly far away. And that's, why we can see the kinds of details, that we can see, right? For sure. So, but yeah, there's a,
What is the difference between this redshift and the TNF method?
Yeah, the Tully-Fisher relationship, that's just a different way of measuring. I don't remember exactly what that entails. There's also a way of of using a particular kind of supernova as a standard candle, as they call it, to measure distances, right? Which isn't shown here. So I'm not exactly sure, like for instance, what this one is. We could look at the reference and actually find out, how they got that distance. But so, there's a lot of different ways of doing it. They're all indirect methods, right? They're based on some kind of model, some kind of a guess, some kind of a correlation that we've seen, right? The only actual way of measuring distances is with parallax, right? The problem with parallax, though, is that they only work for nearby objects. Something like a galaxy is too far away, and you're not going to see any parallax. So it just doesn't work. So they've built this thing. It's called the distance ladder, right? Where they sort of start with parallax, and then based on that, you can sort of go to the next step and the next step and the next step and the next step, and with relatively high confidence, be able to measure distances way out there, right? And that's exactly what they're doing here. So all right, so 32.6 million light years away. That's sort of neighborhoodish, sort of. It's 10 times the distance to the Andromeda galaxy. So it's like I said, yeah, right. I mean, it's not next door, but it's sort of neighborhoody of sorts. Looks like it's moving away from us, and it looks like around 800 kilometers per second or so. So that's a pretty good clip, I would say. Let's see what else we got here. All right, well, let's dive into the papers here. I like that these are ordered by date, because we can look at the latest, hottest stuff, and then if we want to, we can go back and look at the earliest stuff too. So okay, that's talking about the Leo 1 group. I don't know if M65 is a part of Leo 1. Yeah, don't know much about that. Let's just keep going here, see if there's anything particularly interesting. We can actually just do a search for M65 here. Optical and ultraviolet observations of a low velocity type 2 plateau supernova. So a type 2 is a that's a when a single star goes boom. Not quite sure what a plateau supernova is, but I guess that happened back in 2014. Oh, that's kind of cool. Let's just see what that's all about really quick. We can go over to the ADS, which is also an incredible place to find all kinds of archived papers and whatnot. And there's pictures already. I always get completely distracted by the pictures, but I'm kind of interested in seeing what a plateau supernova is. Does that have to do with the light curve being, the brightness of the supernova?
Yeah, it looks like it's how long the brightness lasts. So
cool. Okay.
They last longer than normal type 2 supernova.
Okay, so it actually has its own classification, right?
Its own type, right?
Type 2P. Cool. Okay. So the early spectra are characterized by relatively narrow P Cygni features, which I don't remember what those are. Ejecta velocity is much lower than observed in normal supernovae. Oh, okay. Prominent calcium 2 absorptions. Da, 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 da. So, well, let's see if we can find at least a light curve. You know, these kinds of papers have sort of the, you know, always the same kind of a structure, right? Where you know, there'll be an introduction where they sort of lay out what they've observed, what's going on, all of that, and then they'll get into observations and how they actually, you know, collected the data, reduced the data, you know, turn the data into, you know, some kind of scientifically valid thing, and then you know what they learn. So let's see here. That's okay. So here are some light curves, some optical and ultraviolet light curves, and sort of looks like it's kind of neat that you know, I don't know. I don't know. It doesn't. I'm not really. I'm looking at this over here, and I'm looking at the plots. And
hey, you're still here.
Somebody's there.
That's Ron from Radio. All right, all right, all right.
Oh, Ron from Mert Radio's over. Hey, nice to see you,
Hello,
Ron.
Ronald. How are you doing, buddy?
Hello, doing good, thank you.
Good. So we're
Glad
looking
to
at
hear.
a supernova light curve that happened in Messier 65 back in 2014, and just you know, just doing my random thing here, just following my nose and kind of interested in what this thing was doing. I'm just starting to try to understand this plot, because I'm seeing a red curve here, and I'm looking at the little, you know, table here showing, you know, what's what, and I'm not seeing any red dots anywhere. So I don't know. Anyway, it definitely kind of is interesting, although it's kind of hard to tell exactly what's going on there. There's a big gap in the data. These are modified Julian days. Yeah, I'd have to remind myself exactly what those numbers mean. But anyway, these are basically days along this axis, and this looks like some kind of magnitude, right? You know, depending on, you know, the wavelength being used. But yeah, these particular supernovae have their own type. They're called plateau supernovae. And
what does the colors mean on the picture?
that's what I'm trying to figure out, and I'm not having any luck understanding that at all. I guess I'm sort of seeing these, and I'll zoom in a little bit more so we can see them a little bit better. But these sort of these brownish diamonds here, those sort of look like these observations here, which are definitely indicating ultraviolet, right? UV. So there's a few different kinds of ultraviolet observations here, and a whole bunch of different.
So UV or light spectrum, then, okay.
Correct. Yeah, yeah. So I guess these other ones are just different optical wavelengths. I'm just not quite sure what the colors mean, because I'm seeing I'm seeing the shapes of things, right? I've got filled in circles here. I've got little stars. I've got open circles, and I've got X's. But
Yeah, because normally when you have different colors, you're looking at different properties of space. You know, like you'd have metal, you know, you'd have like gold or silver or iron or whatever. You'd have different colors for the different metals or type of
yeah,
whatever made the planet, for instance.
gotcha. Yeah, I think what they're doing here. I'm just sort of looking at the figure here. They sort of have switched these around a little bit, and now that I'm really looking at it, duh. Over here on the side, here's the I magnitude, the R magnitude, the V magnitude, the B magnitude, and here's the U magnitude, and here are some UV magnitudes here. And they've just sort of distributed these around um, um, so we can more easily see them. But now it's making all the sense in the world. So yeah,
UVOT
yeah,
in the article there. UVOT.
yeah. Well, this looks like a name of some kind of an instrument or something like that. So yeah.
Interesting.
So yeah.
And this was a supernova where?
This took place in 2014 in Messier 65, one of the galaxies in Leo.
Oh yeah.
So okay, all right. So yeah, now that we're understanding this a little bit more, this is making a little bit more sense, right? Really bright in the I and R, not so bright in the V and the B and the U. That all makes sense. But what's really interesting, right, is that over time, depending on what wavelength you're looking at this thing at, there's some significant differences in the light curves, right? I mean, in the U, it just dives, right? It's just gone.
Yeah.
Right. But in the B and the V and the R and the I, it's got some interesting shapes, right? Including, I guess, what they're calling a plateau. That's kind of cool.
So now that's a star that exploded?
That is at least what they think is a single star that exploded. Yeah, a type 2, as they call it, a type 2. In this case, a type 2P. So very cool. Okay, well, I'm not gonna linger too much on that, but I do like looking at the pictures. So yeah, here's just some more.
So now, would that be similar to what when Chinese witnessed the Crab Nebula? That be a similar situation?
I'm pretty sure that the theory is that yes, that was also a single star that exploded.
Wow.
Because we observe it now as a neutron star, which is also pulsating, right? It's called a pulsar. So yeah, I'm pretty sure that at least the current thinking is that the Crab Nebula was a single exploded star.
Okay.
Yeah. Anyway, yeah. Here's some cool light curves too. For sure. So okay. So this is showing a bunch of other similar supernova events. Just showing how similar they are and differences as well, right? And these lines here are usually some kind of model, right? It's like plug in a bunch of numbers, let the thing run, and see what you get out of it. And so yeah, probably based on different models and things, they can extract all kinds of interesting information about these things. But again, I'm not going to linger too much on that. It's always amazes me how much work is done on these things. Just absolutely incredible. I guess the only other interesting thing that I'm going to look for is just what kind of instrumentation, what kind of observations were made. So let's see. So this image was taken with a 2.4 meter telescope. Oh yeah, where are these people from? I always like to find that out too. 1, 2, 3. Let's see, are there? So it looks like mostly Chinese. China. There's a UK there. There's the United States there. Cool. Okay. So I love to see collaborations from all over the place. There is synergy with those kinds of things. So I like to see lots of cooperation, lots of collaboration and stuff. And it's so cool, right? You know, they give out their email addresses. So, you know, if you want to contact them directly, you can, right? It's very cool. All right. So let's see. They were talking something about a 0.35 meter telescope too. Whoop, how'd I get there? Unfiltered image. Okay, so this looks like some kind of a discovery kind of a thing, right? So this is when this object was actually discovered, right? I mean, it's a supernova, it comes out of nowhere almost. So relatively small scope, you know, discovered this. That's pretty cool. But then, you know, they turned quickly to a larger scope, which makes sense, and did some photometric observations. Doesn't look like, did they do any spectroscopy or anything? Don't know. Of course, they used IRAF. Yay, IRAF. I thought I saw something about spectroscopy. Yeah. So a few spectra, right, were taken. Continuum were adjusted. The spectra were further corrected for atmospheric absorption. Okay, so yeah, they did take some spectra. I wonder if they have any images of the spectra here too. It's sometimes nice to see. Let's see. Extinction. Different light curves. Here we go. Maybe. Oh yeah, here's some spectra. So you can see how the spectra evolve, right? So here's along the x-axis is the wavelength in angstroms, right? So this is basically along, you know, the visible bands. And as you can see, you know, first observation sort of looked like that, which was just a couple days after they detected it. And then you can see how the spectra evolved, right? I mean, if you sort of look here, I'm just sort of, you know, picking out features. So right on day 8, we've got this kind of a thing, right? Day 10 sort of changes. Day 12, it's really changing. And, you know, by day 83, that particular feature is, well, it's, I don't know if it's gone, but it has definitely changed, right? Even this, right? You know, this wide thing here, not there at all up here. So really, really neat to see things evolving and changing over relatively short periods of time, right? So it's nice to have access to a telescope, you know, where you can actually do this kind of time domain stuff. You know, because usually, you know, with sort of the larger telescopes, right, you've got, you know, 1 or 2 nights a year. And so, yeah, you know, it's nice to have access to a scope where you can actually look for, you know, several days. Pretty cool. It's nice to see those kinds of things evolve. And, you know, that tells us a lot about this particular object. Don't know what it tells us, but it probably tells us a lot. H alpha here, yeah, so they're identifying various absorption features and all of that. You know, here's the hydrogen alpha line, oxygen 1, I guess they're seeing here, calcium 2, magnesium, iron. Very cool. Okay, and this is over certain days. See, as you can see, as this, you know, you can sort of imagine, right? You know, this thing starts to blow up, and then all this stuff comes flying out of it, and that's what we see over time, right? It's all this stuff.
So if you could have a ship there at the time of the explosion, what would that be like?
I think that would be epic.
If you can survive that.
I think that would be an epic view. Where do we go and when do we go? Because I'm going.
All right.
Yeah, that must be
like if you're on a Starfleet ship, you know, and you have all the force fields you can have around the ship.
Yeah.
You can be safe, you know.
That would be a colossal explosion. You know, most supernovae exceed, you know, the brightness of their host galaxy for quite a while. So you know, just imagine, you know, basically, you know, the energy of a galaxy in one explosion. So that's colossal. But yeah, you know, what that actually looks like, we don't know. You know, we can only observe these from a distance. And in truth, this is what it looks like, right? All this stuff comes blowing out. We can actually, you know, measure, you know, the heights and widths of these spectral lines to, you know, to measure things like temperatures and velocities and brightnesses and all of that, and actually get a pretty good idea as to what it might look like. But yeah, what it actually does look like, don't know. That's a toughie for sure. All right, let's really quick go to the earliest mention of Messier 65. And, oh, that's the wrong one. I grabbed the wrong one. Let's go back to Sinbad. I think I erased the whole screen that I was looking at there. So to go back, we can get it back. 65. Go back to the references. And let's look at the earliest one. I like to do that from time to time. Most of the time, they're just pictures or charts or something like that. But let's see. So 1850, Mr. Messier himself. That makes sense. And then apparently nothing mentioned until 1919. Photographic effective wavelengths of nebulae and clusters. So yeah, you know, back 100 years ago, right? We weren't really sure what these fuzzy blobs were, so we called them nebulae, for lack of a better term. Turns out to be galaxies, right? You know, their own thing. Not quite sure what photographic effective wavelengths are. That's let's see if there's something else here. 1919 again. structure of the galactic system. So they're starting to talk about galaxies here. Radial velocities of globular clusters in non-galactic nebulae. Extragalactic nebulae. From Mr. Hubble himself. Let's do that one. So Edwin Hubble, 1926, Astrophysical Journal. Let's see if there's anything particularly interesting here. Don't want to go too long, but I say that every time. Mr. Hubble himself. Slowly loading.
And when was that paper?
What's that?
And when was that paper?
1926.
Oof,
This contribution,
my time.
yeah, it's a little bit before my time too, for sure. So this contribution gives the result of a statistical investigation of 400 extragalactic nebulae. So they've determined visual magnitudes. The list is complete for the brighter. So, okay, so we may not actually get any pictures here. We might just get a big long list. Let's see if, and again, I'm gonna just fly through this. So there's Hubble's classification system again. Different kinds of nebulae, as they call them.
Can I ask, why are these papers? I presume these are the most up-to-date ones, but why are they so old?
These are the oldest ones. Yeah, I've gone back in time. So,
I beg your pardon.
Yeah. No, they, Sinbad is great about this, right? They list all sort of the relevant papers, and they order it by date. So I like to look at the ones that are more recent, and I like to look at the oldest ones. The oldest ones are pretty cool sometimes.
It's just to me that in so many different sciences that the most up-to-date papers seem to be pretty much the oldest ones.
Sometimes that's exactly true. Yeah,
Goodbye to Tom.
Take care, Tom. All right. Well, here's
all the best, Tom. Mate. You take care, buddy.
Yeah, here's some actual photos. I don't know if they have them all in here or not. Normal spirals. Let's see if they've got any. It looks like they actually do have some pictures here. That looks like the Sombrero galaxy. Maybe it isn't. Maybe it is. I don't know. They've been naming the Messier, so maybe that isn't the Sombrero. Because the Sombrero is Messier 104. But let's see if we can find quickly a photo of M65. I don't know if we're going to be able to or not, but give it a try here. There's some spectra. Wow, so there's a spectrum of NGC 4214. Very cool.
Is that the light emission?
Yeah, it's a spectrum. It's exactly the same thing that we were looking at before, except it's called slitless. So they're just taking the light and running it through probably. What's that, Bobby?
We're gonna also have to take a night to Jim as well.
All right, Jim. Take care. Yeah, I'm about ready to wrap up
take
here
care,
anyway.
Jim, buddy.
I just get completely enamored by all these things. So, but yeah, they just run the light through like a prism, and they get this kind of a thing. So yeah, I mean it's if you were to look at this yourself, it would look like a rainbow, right?
Does that mean that there's no specific focal point? It's just a gathering of the light
Oh,
I
it's
don't know how to
completely in
describe
focus.
it.
Yeah, no,
All
no, it's
right,
completely in
right.
focus. It's just, you know, this light has been spread out to a rainbow, right? You know, this is just a black and white image of a rainbow, right? And so, you know, um, 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 put your own eyes on this, and you'd see, you know, red all the way to violet, right? But because it's a uh, non-colored photograph, right? Just looking at the brightness,
Are you
it's
saying that they're
grayscale.
actually isolating the different wavelengths into strips?
Well, wavelength in this case would go this away, right? So go from red to violet this away, right? And then the
Right.
features that we actually see, I mean, it gets all sort of smeared out and everything, right? So I mean, it's not the best way to do it, but that's you know the technology that they had at the time, and so this is actually pretty spectacular, you know, for that time, for sure. All right, let's see
Whoosh.
here. Whoosh. Let's see if there's any picture of this guy. Okay, it's getting into the tables. There's probably pictures here somewhere, but I don't think I'm going to linger on too much longer. We can, I can post this over on the Discord here, and we can, if anybody's
My
interested.
apologies, by the way, for not getting over there too much.
Oh, that's okay.
That's pretty good at there, you know.
Yeah, as with everything, come on over whenever you can, whenever you'd like.
I must do some of them puzzles too. I haven't visited that last one for a couple of weeks.
Yeah, you know, I've got to post a new one too. I need to do that. Thank you for the reminder. All right. Well, I think I'm going to
Pretty
get
cool.
out of here for now. Yeah, those are really, really
Oh,
fun.
I'm glad I caught the last of the show. Thank you.
Yeah, yeah. Always great to have everybody in here.
Johnny's been playing music since 8 o'clock, so I've been busy with that.
Well, you know, you got your priorities right.
You gotta keep track of that station.
Yeah, very cool.
Yeah.
All right.
Get some bloody rest, Ron. It's nice to meet you face to face, by the way.
Oh yeah, about time, huh?
Yeah,
and
too right.
And your mic works too.
Sorry?
And your mic works. Your microphone.
Yes. Absolutely. All right, buddy. Well, I'm going to get out of here for now. So take care. Have a great evening, a great day. Make sure, you know, to smash the thumbs up if you so desire. Spread the word about this too, right? I'm trying to spread the passion, right? I am crazy astronomer, right?
Hey, Tim, you got my Skype name, right?
You Skyped me last time, I remember, if I remember rightly.
Hurt Radio. Just Hurt Radio is the name.
Yeah. Yeah, I think I've got you, yeah.
All right, good. Just want to make sure.
Excellent.
All right,
Excellent.
good deal.
So when, just really quick, Ron, when's that scope going to go out under a clear sky, a clear, warm sky?
Well, we kind of got to wait for the snow to kind of melt, you know. We got a snowstorm coming tomorrow, actually.
Oh, man.
So it'll be at least another couple of weeks, probably.
Yeah. All right. Well, we got to be.
I'm learning about it. I'm learning it. I'm enjoying understanding it. I finally got it balanced. I managed to get it balanced so it's not going forward by itself. It sits right there and on the arm, you know, and so
Excellent.
it doesn't. And it sounded like the motor was working a little bit easier when I got that balance correctly.
Absolutely. Yep. That'll help a lot.
But I'm enjoying just learning about it, learning what I can use it for my viewing when I do get out. And I will take it with me when I go to New York, so I'll have it there. So.
Oh, very cool. Very cool.
I just want to say this: Trump, my love, you're fake news.
Yeah, and then you know Paul and Keith Sciences, right?
Yep.
Or P and K Science, rather.
P and K, yeah.
Well, I know Keith. I met Keith before. I haven't met Paul yet. But Paul is coming to the Pine Bush event this year. And then Bill said, producer Bill, who's having the event at his house, you know, he told Paul that I was bringing my scope that I just got. And then Paul said, well, good, I don't have to bring mine. So,
well, you'll have to set up a pair of binoculars, right? You can use them both
right.
at the same time. So.
That's right. But yeah, so I'm looking forward to that. And then Andy Morrow, he says, well, yeah, then Paul can show you how to use it.
There you go. There you go. All right, everybody. Well, I'm going to get out of here for now. Peace, cheers, and all that.
All right.
I will see you in, like 22 and a half hours, something
All
like
right.
that.
I'll
be on time. I'll be on time tomorrow. All right.
And anytime you want. We are easy here. You come in and out, whatever you want.
Thank you. Thank you.
Very, very cool. All right, buddy.
Vixen
I don't know about you guys, but I'm itching the bloody hay.
All right. See ya.
So am I. See you later.
Good night, everybody. God bless. Stay well.